rolling.
All right. My name is Richard Red. I'm here representing JMS Integrated Building Solutions. We've provided the integration to the train system that was factory installed. Here's our panel on the second floor of the electrical room. What we have here is the EC Boss, which is basically an integration tool that's used to incorporate it into the existing church facility. We also have an additional controller that's used here pretty much to monitor some points from the exhaust fan, one of the exhaust fans in the building. This panel has to stay powered up at all times in order to be able to see through your network once the network is connected in. Also, on all the train boxes, as I was saying, they were factory provided. What we were contracted to do was pull lawn communication and install thermostats back to each and every box. Once we get the integration online, we'll incorporate that into the job. We'll also see what we can do to help modify the system a little bit more in detail.
Okay.
Ask your question again. Yeah.
Here comes the question. And rolling.
I don't remember my question. So this has to do something with computers.
Okay. Yeah. This Jace here is your integration, as I was saying, in reference to communicating to the front end. Once your Ethernet is in place, that gives you availability to communicate to this device. This power supply must always maintain powered up in order to be able to communicate with the device. If this loses power, you also lose your scheduling throughout the building to the facility. All of the controls right now are set up to default to on. So if you do lose power to the panel, you won't be able to talk to it, but your controls will automatically continue to operate until you change that. That's it.
Y'all gotta be quick with the questions.
Well, I didn't know if we're supposed to ask while that's on or not.
Also, we have on here two ports. One of them we'll set up for the church's direct Ethernet port. The other one, unless you want to use it for an outside port or something like that, we'll use that as what we call a service port. So what we need to do if we come in here to service you, we can directly plug into here without having to go to one of your PCs or something like that.
Okay.
And
More questions.
I'm just going to explain a little bit more detail about the system. Currently you have 4 rooftop units. 2 of the rooftop units, number 3 and number 4, are VAV units. These units, VAV number 3 serves the first floor and VAV number 4 serves the second floor. RTU units number 1 and 2 serve the gym or multi-purpose center. Currently, there's a special design on those units that have dampers that work also like basically a 4-stage system. Above the clouds inside of the multi-purpose center, when one unit comes on, if there's not enough temperature to maintain, a damper on the next unit opens up, and these 2 systems are duct together. So now that you have 2 units, ultimately 4 compressors for 2 units supplying air to that one location. They are communicating and controlling based on one thermostat, but it's basically it's staged through software to be able to pick up the second unit when needed. That is also a heating and a cooling unit in the gymnasium, multi-purpose center, excuse me, and also the 2 units that are VAV units are cooling only unit. They do not provide heat. The heat up here, as the train guy was saying, it only comes from the boxes with fan power boxes. They have electric reheat. Okay.
All right, and rolling.
Okay. The thermostats that are controlling each thermostat, there's 1 per VAV box and 1 per fan power box throughout the building. These thermostats have what they call a push button override, which actually through software can be deactivated. Also, it has a slice that adjusts with a scale currently of 50 to 85 degrees. That also in software can be adjusted to minimize the amount of change in the thermostat.